Today we learned about the last figure on our chart, and it is called the trapezoid. So the trapezoid is a quadrilateral. However, it is a very cheap figure. It only has one property that we need to know, and that property is that only one set of opposite sides is parallel. Everything else in the trapezoid is a no. It does not have opposite sides are parallel. It does not have opposite sides are congruent. The sides are not congruent. Opposite angles are not congruent. It does not have four right angles. Diagonals are not congruent. Diagonals do not bisect each other. Diagonals are not perpendicular. And diagonals do not bisect the vertices. The only property the trapezoid has is that it has only one set of parallel lines. So think about it. If they asked you to prove whether a shape was a trapezoid or not, you would just have to prove that one set of lines is parallel and that the other set of lines is not parallel. We are not proving trapezoids today. We are just using equations based off of the property we know. So here we have an example problem. This is on page 80, number 1. It says, JKLM is an isosceles. Isosceles, very important word, which means it has two congruent angles at the base. So two congruent angles at the base and two congruent, that doesn't look so good, and two congruent sides as the height. So here we have an isosceles trapezoid. We know that this angle is congruent to this angle is congruent to this angle, and this side here is congruent to this side here, all because of this little word here, isosceles. So it says isosceles trapezoid with JK parallel to LM, so JK is parallel to LM, oh no, let's switch those, LM, and it has a median of RP. So a median in a trapezoid is the line that is parallel to both bases and it cuts the height in half. Okay? It's located right in the middle of the trapezoid. It's called the median. Okay? So the formula for the median of a trapezoid is base 1 plus base 2 all over 2. So it's basically the average of the two bases, of the two bases here and here. Okay? Which makes sense, because if you're trying to find the line that's directly in the middle of this one and this one, you would probably find the average of the two bases, right? So the formula makes sense. Let's use this formula in the problem. So it says find RP, or find the median, if JK, let's make a new figure with the measurements so it's not so gummed up from up here. Okay, so we have ML, JK, and RP. Okay, so the figure says, find RP if JK is 2x plus 3 and ML is 1/2 x minus 1. Okay. So let's look at the formula up here. We're trying to find the median because the median is RP. And we know the first base is 2x plus 3. And the second base is 1/2 x minus 1. And those are all going to go over 2. So they tell us here that RP is 5 plus x. Oh, okay. So this piece here is 5 plus x. So we can substitute that in where we put the median. So we have 5 plus x. Okay. So now we have this one over 1, this one over 2, 2 here, 1 here. We get 2 times 5 plus x equals 2 times x plus 3 plus 1/2 x minus 1. So now let us distribute on both sides. We have 2 goes here, 2 goes here. We get 10 plus 2x equals, oh, sorry, that was kind of messy. We get 10 plus 2x, why does it keep doing that? Equals, we distribute here, we get 2x plus 6 plus 1/2 x minus 1. So now we have a 1/2 here, a 1/2 x here, and we are going to have to deal with that soon. But first, let's combine our like terms. We have positive 6 over here, minus 1 over here. Let's get 2x plus 1/2 x plus 5 equals 10 plus 2x, okay? So now we get minus 2x here, minus 2x here. Those 2 x's cancel. We get 10 equals 1/2 x plus 5. I move this 5 over, minus 5. I get 5 equals 1/2 x. I need to put this 1 over 1. I do 2 here, 1 here. I get 10 equals x. Are they asking me to just find x? No, they say I need to find RP. RP is 5 plus x. So now I need to substitute in the 10 that I found. Oh, let me put this under the x. I need to substitute in the 10 that I have found to get the RP. And RP is going to be 15. We got 15, that is the answer. We're good. So now we need to find the measure of each base angle. So a base angle is going to be this one here and this one here, as well as this one here and this one here. If ML, the measure of angle L, is x, and the measure of angle J is 3x plus 12. Okay, so in a trapezoid, this angle plus this angle gives me 180, and this angle plus this angle gives me 180, just like in a parallelogram. So that's going to be my equation now. I'm going to erase this. I hope you got it. Okay. So that's going to be my equation now. I get 3x plus 12 plus x gives me 180 degrees. Remember, there's 360 degrees in every quadrilateral, so it makes sense that this angle plus this angle is 180, and this angle plus this angle is 180, because that gives us a total of 360 degrees. So now I have my equation. I combine my like terms. I combine 3x here. I combine x here. I get 4x plus 12 equals 180. I subtract 12, I subtract 12, I get 4x equals 168. Divide by 4, x equals 42. So now I know if I substitute this 42 back into my figure, that this angle, oh my goodness, why does it come out so messy sometimes? That this angle here is going to be 42 degrees. This angle here will be 42 degrees. And we know that opposite angles add up to 180 degrees. Or we can just substitute x back into this one here. We get 42 times 3 gives me 120 plus 6 gives me 126 plus 12 gives me 138. So I have 138 up here and 138 up here. If you check those numbers here, they all add up. So now we are going to do another type of problem with trapezoids. It says here that an architect wants to make a plaza in the shape of a trapezoid. 3 of the 4 corners of the plaza are -7, -1. Okay, so this one here. -1, -7. Okay. 4, 6. And the fourth one, we don't know. The fourth corner of the trapezoid, we don't know. But we know that it is in the first quadrant. So the first quadrant is labeled right here as the first quadrant. So we know it's going to be somewhere over here. Okay, let's connect these lines and kind of get an idea of what our trapezoid is going to look like. So now this trapezoid is not an isosceles trapezoid. It doesn't tell us that. So we just need this line here to be parallel with whatever line we find up here in order to create a trapezoid. So let's find the slope of this line here, AB. We go down 1, 2, 3, 4, 5, 6, 7. So we go down 7, and then we go over 1, 2, 3, 4, 5, 6. We go over 6 units. Oh wait, no, I added an extra unit here. We go down 6 units, and then we go over 6 units. So if our slope here of this line is negative 6 over 6, it's going to reduce to negative 1, right? So I need to find a point that has a slope of negative 1 in order to find a line that's parallel to AB. So if I go down 1 and over 1, I could have a point here. If I go down 1 and over 1, I could have a point here. If I go down 1 and over 1, I could have a point here. So any one of these points could work because it's still going to give me a trapezoid here. I would just connect them like this. It could give me a trapezoid here. I would just connect them like this. Or it can give me a trapezoid here. I would just connect them like this. But if we were to make an isosceles trapezoid, we could put the point here and just say it's 6, 4, or we could give any one of these other answers.